Welcome back, fourth grade engineers. We are back in Ergstown. Today we are on lesson 2.1, activity 2, and it is called Energy in Electrical Systems. Let's review our unit question. How does the electrical system work? So everything we've been doing up until now, and we will continue to do, is going to help us figure out how the electrical system works. So let's look at this. This should look familiar. It looks like the simple electrical system that you built. First, I need you to think about the parts of this electrical system. I have this part. You see my cursor moving over it. I have these. I have this yellow thing, and there's something behind it. What are all those parts? So we have this. What's that called? That's right, a solar panel hooked to these black wires. Behind this yellow thing, this fan blades, was what? It made it move. That's right, it's a motor. We will need to have those parts in order to do what we're going to work with today. So I want you to first think about what is the energy source in this system? Where did the energy come from? If you say the sun, you're correct. And I want to know what part of this system converts the light energy from the sun to electrical energy. So remember, we talked about the parts. Which one is converting the light energy that comes in from the sun to electrical energy? If you said the solar panel, you're correct. Now, which part converts that electrical energy that came into here to motion energy? So I'm thinking, what is causing something to move? That's right, you can't see it very well, but it is the motor. Who said the motor? You're correct. And then last but not least, what part were we able to observe moving? If you said the fan, the blades here, you're absolutely correct. Now, we did a simulation, and you're seeing a simulation being put together here, and we can use it to create something similar to that simple system we just saw. Now, it's not going to be exactly the same because there isn't a motor with the fan on it, so we have to do something a little bit different. So we do have the sun, as you see was added there. We have a solar panel, but instead of just having the fan, we have a motor. And then we use this flywheel. That's what we're going to use to be our fan blades because it's the same kind of movement. Who can predict what will happen when I press the run button? When I press run, what's going to happen here? If you said, let's see, let's watch this video. Here we go. All right, let's see what happens when I press run. Watch here. Okay, this is going a little bit fast here, but we are going to wait till all the energy is transferred out of our sun to see what happens. We're going to watch or observe what happens when the system continues to run for a few seconds. What do you notice happening? Once it's run, we're going to analyze it by pushing the Analyze button. And this time we're going to be able to see this graph. What's coming in to the system, what's going out of the system. I can drag the slider below to show any part of the system that's being run. So if I drag it back to where it starts and we play it again, we can see what happens to each of these graphs. So I press play again and watch these graphs. So as the energy decreases, that's coming in, the transferred out increases. So watch the yellow get lower and the red get taller. Okay. So when in our little simulation, we had some energy being transferred out of our system. If I look, I I put the graph here for you. We're going to energy transferred out. What kind of energy? What form of energy is it? I'm looking here. These look kind of similar. This is saying, even though it shows a squiggly line, it shows red. Red means thermal energy. That means heat is coming out of it. If it was blue, it would be sound. If it was orange, it would be light. Now, I want you to add the number for our thermal energy, that's our transferred out energy, to the transferred in energy, which is 78. So if I add 22 plus 78, what do I get? 8 plus 2 is 10. I carry my 1. 7 plus 2 is 9 plus 1 is 10. That number is now 100. Do you notice that it equals my energy transferred in? So whatever comes in to my system equals the energy in the system plus the energy that gets transferred out of the system. So I'm looking here, and I hope you can notice that there's some red squiggly lines coming out of my flywheel. Remember, our flywheel is the same as our fan. What form of energy are those red squiggly lines? If you think about it, it kind of looks similar to what our graph at the bottom. The red squiggly lines represent thermal energy. So what you're going to do is you're going to use our sim to create two systems. One that has light as an energy output and one that has sound as its output energy. Let's do one together. Now you won't write this one down because I want you to make your own, but I want you to know exactly how it works. So if you look on page 23, we'll go through the directions together, we'll make one, and then you'll be able to make two on your own. So the directions say, so in your investigation notebook, page 23, build and run a system in the sim with light as an energy output form. Think of a name for the system, something logical, please. And you're going to put it in the first column, right here under system name. In that same row, remember our row goes across, you're going to record the parts of and what the electrical device is and what the output energy form, or forms, because there could be more than one. Then you're going to do the same in the second row, but this time it will be sound as an energy output form. Okay, so let's try this. All right, so here is my system. What should we call it? Well, okay, I've got a sun, I've got a solar panel, I've got a motor, and I've got a flywheel. So maybe something to do with that. How about solar electric flywheel system? Kind of logical. Okay. Now I want to think of all the parts in my system. So I have the sun, I have my solar panel, I have my motor, and I have my flywheel. So I'm going to put the sun, the solar panel, a motor, and a flywheel. So I'm just going to list my parts. The next thing is, what is the electrical device? What is the electricity coming into? What is coming into? Is it coming into the solar panel? Is it coming into the motor? Or is it coming into the flywheel? What do you think? If you said motor, you're right. Now, so the electricity is coming into the motor, and the motor's moving, and what is its output energy? So we have, it made this flywheel do what? It made it move. But remember, in our picture, it also had the little squiggly lines coming out of it, and that represented thermal energy. Okay, so it had both motion energy and thermal energy. It could have both. So the motor converts the electrical energy into motion energy and into thermal energy. All right, so now, in case you need a reminder, here is how we open our sim. You're going to click on Amplify Science in your bookmarks. Okay. Then you're going to choose the energy conversions unit. It should look something like this. And you're going to click on the orange box with a 1 to access our sim. Our job will be to create 2 different systems. Remember, one with a light output and one with sound output. And fill in all these parts. We will need this for our next activity, so make sure you do this. And here's your reminder on your Chromebook where you should go to do this whole thing. Hopefully you have the username and password written down. If not, here it is again. Please write it inside the front cover of your investigation notebook if you haven't already. And you will have this assignment to add to your seesaw. So good luck, have fun, and I'll see you next time.